Mr. Rice, Mr. Gonzalez, this is Jared with Texas Drone Company, and I was just wanting to go over this map with you just a little bit. There are one or two things that I just needed to be able to explain to you, than rather just include them in an email, so I thought I'd make a quick video. Here you can see the map. This is what we call the false color elevation model, and basically it assigns a value from cool to hot based on the altitude. Relative to the model itself. So dark blue is very, very low, and red is obviously higher. So these are the trees that you would see on the new property, and then this is where you've currently dug down to. So I did set a calibration point right here. This calibration point is kind of the zero of the map. We just called that 0 for reference, so that when we take these measurements up here, we can reference them against something, and it'll kind of give us, that way we can click on a point up here and see how much higher is this point up here than this point here, or a point over here, how much higher is it than this point down here. So this is an arbitrary 0, it's just something that we set. So what we're going to do is look at some lines that I've made, and in this first line right here, let me zoom in a little bit, is kind of from the top of that new property down to the bottom of the pit. We tried to see as much vertical slope as we could. So you'll notice that down here at the bottom, this graph over here represents the length of this line from left to right, from left to right. So you can see at the top we're at about 38.25 feet, and then that drops down to about 0.89 feet above this point over here. So for all intents and purposes, we see about a 37 foot drop here from the top of here down to here. We'll move up to this line here, and you can see there's a little bit more of a shelving to it, simply because that's, you know, reflective of what's over here. So up here at the top, we were at about 41 feet, all the way down to the bottom of about 3 feet. So this point right here is 3 feet higher than our calibration point. This point right here is 41 or 41 feet, excuse me, higher than our calibration point. And this right here is a little piece of equipment. Well, I shouldn't say a little piece of equipment, but this next line, you can see we're still at about 41 feet above our calibration point, dropping down to 6 feet now. So this point is now 6 feet higher than our calibration point. This next point shows the shelf pretty well, at 35 feet. So we start to see this sloping back towards the road, from a high of about 41 feet down to about 9 feet. Now we're about 9 feet above our calibration point. This next point, we see the berm, that's denoted right here, and then we're at about 19 feet above our calibration point and 25 feet. So this is about 6 feet. And then up here towards the entrance, we see the berm is at 23 feet. So you have the 3 foot berm, and we're 20 feet above our calibration point way up here, and it's about even across as we would expect. So this is just a quick example of showing you how we can quickly see elevation differences, take those measurements, and be able to know what we're looking at. And so if we're able to draw a line across this pile, then you can clearly see how the pile is shaping up. It follows the contours across. So the pile is about 33 feet high at this point here, and 29 feet at this point here, relative to our calibration point. So if at the base of the pile is 4 feet above our calibration point. So thought I'd just show you that as a quick explanation. I hope I can answer any more questions that you might have, and go over it with you. Using some of this technology, we are able to provide a rough estimate of what volume we think is in this property using our lowest calibration point down here, and I'd love to go over that with you if you're curious. Thanks for watching.